So welcome to this webinar about the Airlock Microgateway. My name is Martin Burkhart, and here with me is my colleague Stefan Dieitiker. We both work in the product management team at the Airlock department. So what are we going to hear today? The webinar has three parts. In the first part, I want to have a look at where are we coming from, where are we going to regarding security architectures. Why do we actually need Microgateway? Is this just another hype, or are they actually useful? And in the second part, I want to go more into details about Airlock Microgateway releases, new features and capabilities that have been added recently. And in the third part, we will have a look at the demo and see actually Airlock Microgateway in action. So during the webinar, you see a question tab on the control panel of GoToWebinar, so you can add questions there. And I suggest that we look at the questions after each of the three parts and try to answer them directly. Okay, so there's lots of trends transforming the way we work in IT or using IT. I'm sure you're familiar with most of these. So in the past, we were used to long release cycles of software. We had waterfall process models. Today, we try to work in agile mode, DevOps, merging development and operation practices. Continuous delivery is actually the goal. And when we built websites, we used classic HTML websites with a request and response paradigm. Today, if you build a modern web application, it's a single page application with lots of JavaScript logic in the client that will use APIs in the backend. And we have mobile apps. That's also an additional type of application. We come from building monoliths, everything in one piece. Today, we're aiming for microservice architectures. We have been building security as a perimeter type of security, separating the bad outer world from the good inner world. And today, we have learned that this may not be the right level of separation between good and bad. We need to think in terms of zero trust, and each service should actually protect itself. So here's a classic architecture where that actually represents this perimeter security paradigm. On the left, you have clients trying to access the protected services on the right. And in the middle, you have some type of security products. Here it's a secure access gateway connected with an IAM solution. And you have lots of functionality that you're actually solving here centrally. So typically that's a reverse proxy here. So you're not publishing the services directly to the internet. You address OWASP top 10 threats here. You handle TLS security certificates. You do authentication and authorization of requests. You may monitor API usage, for instance. And with regard to operations, there's typically two roles responsible for this infrastructure. So one we have is the gateway administrator and some representative of the development team. And the problem now is that on these access gateways, you have a mix of global policies that are shared for all services and service-specific policies. So that's the blue ones here. Global policies may, for instance, be some threat intelligence feeds that would allow you to block access from malicious clients, and you want to block that for all services. Or you may have some Let's Encrypt service included also that can be used for different services. But depending on the service, you may have different technology in use. So the one or the other feature on the gateway may not be applicable for service A, but it may be necessary for service B. So you will have parts of the configuration that are very specific to a service and parts that are common to all of these services. So what now actually causes problems is that these two people, the administrator and the developer, they have different perspectives on how to deliver a service. So the administrator is typically interested in publishing a service securely. And he understands little about the domain of the service, and he's afraid of false positives. So if the gateway blocks a certain type of request, he's not capable of saying whether that's a true or a false positive, because he doesn't understand the business of the service. And the developer, on the other hand, for him, typically everything works as long as it doesn't go through the gateway. So it's always the administrator's fault if something's broken. He's interested in releasing quickly because he may have business having a fixed deadline for go live, and he's not so much into operations and guidelines and checklists that are relevant for the administrator. So that typically leads to what I call the delivery back and forth ping pong type of process. So I've just tried to make some bubbles here, what they could be saying. I'm sure you have heard one or the other of these phrases in your environment. So there's a new release from a developer and wants to go live with it, and the administrator says, okay, that's fine. We have a maintenance window in 3 weeks. And the developer does not understand. He's used to continually deploy his services. What, 3 weeks? No way. It must be as soon as possible. And for the administrator, he's kind of irritated already and says, okay, yeah, that's an emergency change for us. But yeah, okay, let's do it. And then usually it doesn't work. At the first shot, the admin has to change something, goes back and forth, but suddenly the second developer appears on the scene and says, what have you been doing? My service is broken. Okay, so maybe the administrator has changed something on a shared policy that actually affected service B. So he reverts the change, the developer tries to help, implements a workaround, and then the contact on the gateway side goes into vacation, and some deputy shows up starting to think for the first time about the problem. And now the developer is kind of annoyed and says, no, come on, we're late already. That can't be true. So finally, there's also a warning in the log file and talking about suspected attacks and complicated things. And the developer says, well, no, make an exception. We have to go live now. And that's a good point in time for the CISO to show up and actually have some questions. So what we see is that this mix of shared and common policies on a single device, together with two different perspectives on what the delivery of a software piece should look like, cause problems, and in the end will result in lower security. So if we look into literature, how we should actually secure microservice architecture, there's some proposals, some blueprint architectures. So one I found here is from Gartner, how to build an effective API security strategy. And what we see here is that there's not only this central gateway here called Edge Gateway, but there's microgateways. So the light blue column in the middle, that's actually a new thing. And how are they different? So what Gartner says here is that the Edge Gateway is supposed to authenticate clients and then inject a token into the request stream containing information about the client. And microgateways are then deployed closely to the services, and they will simply validate these tokens. And similarly, there's an O'Reilly book about securing microservice APIs, and the orientation of the picture is different, but the content is very similar. So you have here an API gateway at the boundary of the outer domain, which communicates with an authorization server and an internal certificate authority, and allows to actually create tokens. Here a JSON Web Token. They can be attached to requests going towards inner domains and services. And there again, you will have a hierarchical endpoint, and you could easily translate that role into the microgateway role as depicted in the Gartner picture. So in our setting, that would mean that we could actually move these service-specific policies, the blue parts, more closely to the services where they are actually developed. And that's exactly where the microgateway comes into play, because you can enrich your architecture by having these microgateways here depicted by the circles in front of the services. And this actually allows the developers to have a very tight security configuration close to their service, and they're responsible of it. They can integrate it in their build pipeline, and as soon as a new feature is developed, they will see whether there's a false positive, yes or no, and they are actually capable of deciding whether that's a security issue or whether that's something the application requires and must be added as an exception, for instance. So if we separate responsibility in this way, then software deployment could be a lot smoother. So when the developer has a new service, and think about the back and forth ping pong, then at this point, the security policy of the service is already integrated on the microgateway, and the gateway admin doesn't have to care about it actually. It just needs to add a route through the gateway, and typically there's some APIs, so you could probably have an automated way of registering the service on the gateway, and if everything went okay, then that's all there's to do. And the developer can easily publish new releases without the gateway administrator having to be involved. And the CISO, of course, he needs to be present in a more overseeing way. He needs to produce guidelines, but if he knows that company-wide there's this microgateway in use, he can actually build templates for the configuration and can say that's the way I expect the microgateway to protect the services. And if a developer has to add an exception or discussing things, then he can go to the CISO and get some exclusion from a certain policy if required. Okay, so that's the first part. Now let's have a quick look at questions. Okay, I don't see anyone having a question. So feel free to add your questions in the tab. Otherwise, I will simply go on. So now talking about the Airlock Microgateway. The release 2.1 has been published in July already. Release 3.0 is about to be published. Could even be today or tomorrow, but certainly by next week. So 2.1 is, so first you need to know that the security engine within the microgateway is shared with the Airlock Gateway appliance. So you can use the same policies on the gateway and on the microgateway. So that's what I mean here with the gateway core. So 2.1 is based on Airlock Gateway 7.6, and 3.0 will be based on 7.7, which is also about to be released very soon. 2.1 is a non-breaking update, and it has substantial extensions of the domain-specific language. I will show details on that on one of the next slides. But the main new feature of 2.1 is a community edition. Also, I will go into details. So that means you can use it without a license for free, but it has restricted functionality. And 3.0 it adds the option to use JWKs, so that's JSON Web Key Sets in combination with JOTs. So that the JSON Web Tokens it can validate, it can now be configured using these key sets. And the important thing is that these can be on a remote server, so you can actually configure a remote URL, which will then be used for synchronizing new key sets without changing the configuration of the microgateway. And we have added a YAML schema for validation of the configuration file. That's also nice for IDE support. So the developer environment can actually import these schemas and then support you in creating a valid configuration for the microgateway. And again, we have various extensions to the DSL. We have extended also the Minikube example, which you will see in the third part during the demo. And we have added tutorials for self-study to the manual. So the DSL, the domain-specific language of the microgateway, that's actually a YAML file. So the syntax is YAML, and the language is specific to the microgateway. And I think that's a very important part of the microgateway. So when you come from an appliance setup where you have a graphical user interface and you need interactive mouse clicks to actually change a policy, that's a deal breaker if you're going into automation. If you're doing DevOps and continuous deployment, you need an automated way of changing configurations. And this YAML file is actually exactly used for that. So you can use GitOps, you can check in a patch very easily, you can merge different configuration files. And in the first versions of the microgateway, the DSL was limited to the most important features, and you could use mapping templates from the appliance as a workaround for that. And our goal was to limit that to corner cases. So our goal is that you can go all the way using the DSL, and we have added a lot of settings that are now natively available in the DSL. Then I've been talking about the Community Edition. You see here a list of features and capabilities that are available both in the Community Edition and the Premium Edition. So on the bottom you see some advanced application protection features that are available only in the Premium Edition, but they are available in some way, and it says here log only. You can actually use the feature in the Community Edition, but it will only log the behavior that the microgateway would actually perform. So if there's an attack based on HTTP parameter pollution, then it will produce a log message, inform you that this is the case, and in the Premium Edition it would actually block these requests. But you can test drive all the features of the Premium Edition using the Community Edition. And another important difference is the support level. We have a community support forum for the Community Edition, and we have a premium support for the Premium Edition. So here's more details about this public forum. You also see the URL. You can easily create an account if you want to ask questions or comment on questions. Airlock will have a look at the forum and will moderate it and occasionally also answer questions, but that's not kind of a guaranteed way of getting support. So we will restrict ourselves to giving hints, pointers to documentation, best practices. We will not analyze your case in detail. If you require that, then premium support is the way to go. We will try to actually reproduce your setting. If you run into a problem, we can advise you and also help you with integration. Documentation is another important step. We have significantly extended the documentation since version 2.0, and the goal is that it's becoming, or I would say today it is, a standalone documentation. Since lots of the security concepts are in common with the Airlock Gateway appliance, lots of the basic descriptions have now been also included in the Microgateway manual. And in earlier versions, you were then redirected to some chapter of the Airlock Gateway manual. And also it has been restructured around tasks an engineer would have. So for instance, informing them about the basic architecture, about configuration, about operation, about monitoring. And also, you may know that there's Airlock Academy courses where you can get a training for Airlock Microgateway and the other components of the Secure Access Hub. We are using here synergies between the manual and the Academy, so that you will not get a different experience when you finish a course and then open the manual. Okay, release 3.0, as I said, it is about to be released very soon. JSON web keysets, I already mentioned that in the overview. So that's used when you're using JOT for access control. So what the Microgateway can do for you is validate these access tokens. It can decrypt them if you have the keys available. You can extract claims from the token and use it for access control decisions. So you can say there's maybe a different claim like authentication quality. You could make a difference between authentication only with password or a two-factor authentication, and then giving access to different regions depending on that. That's actually something you can do. And as I mentioned, you can have these key sets on a remote server. We will update the key sets that allows for an automated way of rolling over keys without actually having to update the configuration. And these keys are also cached in case the remote server becomes unavailable for a short period of time. Then, as I mentioned, the YAML schema, it's very, very helpful if you try to start from zero, from scratch, and try to develop a Microgateway configuration file. It gives you code completion. It will suggest like keys you could use at this point in the tree. It will give you documentation in a tooltip. If you hover over an attribute, it will show you the texts that you see in the manual. It will check syntax. If you have a typo in there, you will see it directly when developing the configuration file. So that's very, very helpful. Last but not least, we try to make first steps very easy for new Microgateway users, and that's why we have added tutorials to work through in a self-study way to help you getting started, to give you ideas on how to protect the backend service in a first step and add specific features like OpenAPI validation, for instance, or how to handle deny rules. Okay, that's all for the second part. If I see that correctly, there's still no questions. Of course, you can always add them, and we can also go through them in the end. But now, Stefan, if you're ready to take over.
Yes,
we're
I
happy to see
will. I need to go forward to the correct slide. Yes. Before I start to show you exactly how Airlock Microgateway could work in a setup, I'd like to explain you the architecture I'm using for this demo. What we have here is the Airlock Minikube example, which Martin already mentioned. It is publicly available, so if you want to test around or play around with it, you could do that quite easily after this webinar. What we have here in this gray box is a Kubernetes cluster, which has Argo CD deployed. Argo CD is a GitOps tool which will bootstrap all these corresponding containers, including Microgateway. We have here in front clients, could be a mobile client or just a browser, which opens or which sends a request for a particular application. The ingress controller will forward the request depending on the entry path to the corresponding microgateway. We do have here Grafana. Grafana is a user interface to show the Prometheus metrics. So all microgateways will provide a few metrics which are collected then by Prometheus and are queried by Grafana. So this way you could easily see what is going on in your environment regarding your Airlock microgateways. We do have one backend here, a simple echo server, just to show how we could protect a specific application, how you could configure it and bring here security in place. We do have also logs, which means we have Kibana to visualize them so that you can analyze what is going on in your system. All the logs are logged on the standard out, which means in the Kubernetes clusters, they are stored in this directory over here. Fluentd then grabs these logs, pushes it in the Elasticsearch database, which is then queried by Kibana. All these three web applications are protected with authentication enforcement. So this means the user must be authenticated first. This means that we have an identity and access management service in place, which is Airlock IAM, and Airlock IAM also has a database with the users in it. And three of these Airlock Microgateways share a session database which holds information about the session. So what kind of credentials a user has, or what kind of roles he has achieved, what kind of cookies maybe a particular backend has created and should be sent back whenever the user is accessing this backend. This is mainly the whole demo environment, and before going on, I'd like to show you the use cases I will present to you. It is easier to see it in a graphical way than just seeing some requests in a browser. So the first use case would be authentication. A user wants to access this echo server, and the Airlock Microgateway will then see the user is not authenticated, will be redirected to Airlock IAM, where the user must enter his credentials. Airlock IAM will then redirect, after successful authentication, the user to the echo server. Doing so, in the response, JWT token will be set in the cookie to the client, which is then sent to the Airlock Microgateway, extracted, and if the JWT is valid, the user will have access to the Echo server. But not only that, but also all the roles are set in the session. So if the same user is accessing in the same session other services, he don't need to authenticate again. He already has a single sign-on. The second use case I'd like to present afterwards is deny rules. So a request with an attack string is sent to a particular service. And of course, we do want that this kind of request is being blocked by Airlock Microgateway and not sent to the backend service. The next use case will be login and reporting. So we will have a look into Kibana. How do we see what is going on each of these microgateway? How can we manage such an environment and have everything under control? And last but not least, we will have a look into the Grafana dashboard and see how all these metrics generated by the Airlock Microgateway, collected then by Prometheus, will be visualized in Grafana and what kind of information we see over there. So enough slides. I will move over to my browser and show you exactly what I've prepared for you. One sec. Okay. So the first use case is that I'd like to reach a particular service which requires authentication. What I do see here in the developer tools is that there is only a session cookie because I already opened this website, but nothing else. After sending this request, I'm presented a login form mask. I enter my credentials. And what we see here, Airlock IAM has set a cookie, which is the JWT token, and I'm redirected to my originally service, and Airlock Microgateway granted me access. So once I'm here, I could be an impossible attacker, and maybe I could send an attack string. And those of you who already are familiar with the Airlock Gateway, we block this kind of requests, and we also do this with Airlock Microgateway. We see this error page containing a request ID, which we can then use in the Kibana stack to look what was going on in my environment. I already mentioned in my slide before that once I'm authenticated by Airlock IAM, I do have single sign-on. I'm presented now with the Airlock IAM portal, which shows me all the application I can access to. So I simply can open Kibana, Grafana, without requiring to enter my password again. And now we can have a look into Kibana, so how the logs are visualized and how I can drill down if there are any issues. Kibana and Elasticsearch is deployed. I already mentioned that. And what we have here are the reporting bundle deployed in it. These are the same saved searches which are available on the gateway. So pre-configured saved searches which are very helpful in order to drill down a particular problem. On the left side, we do see many fields. Some of them are Kubernetes related, so what kind of image is being used, what is the namespace the container is running in, what is the pod name, and of course many fields which are being logged by the Airlock Gateway, a Microgateway. We can collapse one of these documents and see more in detail what Airlock Microgateway has seen. We do also have a correlation ID, which is logged here. This is an ID created by the ingress controller, and we do enrich our log with this ID. This helps us to investigate which component has seen what regarding a particular request. If I switch back to my request, which was blocked previously, I can simply copy and paste the ID. And what we see here is that there was a request. The action was the request was being blocked. And further analysis would be quite easy to find out what was the reason. For example, it is showed here that it was a deny rule. But we not only have logs and visualization of them, but also we do have dashboards, which helps much more to see where is my biggest problem in my environment. I can select the time frame I want to look for example, an hour. And since I had running a load generator, I see a few logs were being logged after 9 o'clock. I also see there are many kind of attacks being logged and also from where they are coming from. The attack heat map shows me which application is affected most by blocking requests. Quite often it's very helpful to have an idea which application is used the most and how many requests or sessions do I have. How fast are the requests being handled by Airlock Microgateway and how many blocks I have. This table over here shows me what kind of applications are deployed and what is going on regarding the traffic. Whenever you deploy an application, some of them might have issues, at least when there is a maintenance window and you roll over to a new version, or sometimes if there is a network failure or whatever. This dashboard helps you to identify very easily what kind of problems have occurred at which day and time and what was exactly the problem. It is also interesting to know, sometimes also for the development, to know what kind of user access my web application. So which are the user agents being used to access a particular web application? Or how many users do I have on my system? What are the mappings being used? What is the exact language? So in which language do I need to develop my application? All this kind of information are visualized within this report over here. The reports I just have shown are mainly from Airlock Microgateway, so filtering related, but we also have dashboards, so reports for IAM, which is also deployed in this scenario. So this allows me to see very easily what are the top logins which are used, so which is the user which logs in most and what is the factor he's using. So in my setup over here, we do have only username password, but in your environment, there might be also a second factor in use. This is about logging and reporting. Now I'd like to switch to Grafana. Grafana is the tool which visualize the matrix, the Prometheus matrix provided by Airlock Gateway, a Microgateway. Excuse me. On the very top, we see the throughput. We have a throughput license. So I have ordered a license for 20 requests per second. I do see here what was the throughput of each service for a particular time. So I can easily see whether I do have a too huge license or I need to send an email to my salesman and order a higher license. The workload is also displayed. So how much work does every container, every microgateway container have? So whether the microgateway should be scaled horizontally or not. But as you see, they are most of the time just idle and waiting for new requests. Another visualization is just how many requests I have per each namespace, service, pod, or the session information, how many sessions are on my system, how many of them are authenticated, and timing information. With this information, I do have the overhand of my environment and can easily foresee problems and resolve them quite easily. As a last thing, I'd like to show you the configuration, how it looks like, and especially show you one major thing, one major feature in the 3.0, which is very useful. This is the JSON schema, which helps me during configuration to have completion of my configuration. So what are the possible options of this configuration setting over here? And if I configure something which is invalid, I already see during configuration that this setting is not fine. Besides that, I do have a tooltip info, which already helps me to configure this setting to find out what is required without going into the documentation. This is one of the major features which comes with Microgateway 3.0, which will be today or at least or latest next week. Yeah, this was the demo of Airlock Microgateway. I look over to the questions board whether there are new questions. I don't see any of them. So I'd like to thank you for your attention. My colleague will send you a link for a survey. We are very interested to know from you how we can reach you best. So the questions are around marketing channel we should use. We would really appreciate if you could take part to this survey, and I think it would take more or less 2 minutes to complete this survey. I thank you for your attention. I wish you a nice day. Bye.